Hi there. So today I'm going to talk you through how to step by step access the online open access tool that's been developed to help you analyze your drinking water system data, however, that data may be coming to you. So this video, along with this Word document, are available to use complimentarily to the webinar that was given as part of the Small Water Community Network webinar on December 6th. However, it can be used as a standalone, and it's just a quick guide on how to set up your account and download the required software to access this open access tool. So without further ado, we are going to get started. So I'm going to be following along with the steps laid out in the Word document and then just show you my screen and what you would see on your end as someone who has no account, has maybe none of the software downloaded, and how you can go from step one all the way through to the end to actually access the tool. So the first step here is to set up a GitHub account. And GitHub is just a free, basically, repository where folks can upload their tools that they've developed or documents about different projects or code snippets that are useful for the public. And so you're able to access any of this information freely if you can set up an account. So I'm going to take you through how to do that. So first we're going to click on this link here and go to github.com and sign up for an account. So this will take a minute to load. And this is what you're going to see. This is the opening page of GitHub. And so what you want to do is sign up because we have no existing account. And so it'll take you through step by step how you can sign up for GitHub. So first you want to enter your email address. So for me, I'm going to use a dummy email since my personal email already has GitHub set up, just so you can see exactly what you would see on your end. So I'm going to enter my email here. And then I'm going to create a password. So whatever you want. For me, it's saying I need a different password here. And then a username. So I'm just going to use a default username here. And I don't want any product updates, so I'm not going to click that box. And then we need to verify our account. So we're going to click on this green box here saying verify. And we're going to use the arrows to rotate the animal to face in the direction of the hand. So we're going to match that angle so you can see it's facing the direction of that hand. Submit. And then you'll see that now the last step to create our account is to enter the code that's been emailed to us. So this is to the email that you would have entered. And so I will click on my email and I can see that I got an email from GitHub. And so I'll take this code and copy it and go back over to GitHub and enter it here. And there we go. Now we have a GitHub account. And so that I'm just going to skip personalization for now for demonstration purposes, but you're welcome to do that on your end. And so now we have our own personalized GitHub account. And so with this account, this is how you're going to search and find the tool that has already been developed and is open for you to use. So this is step one. So now we're going to move on to step two. So we've set up our GitHub account, and the next step is to install Anaconda. So Anaconda is just a operating system for how you will interface with the open tool. And again, it is a free open access tool, open access operating system, I should say, where once downloaded, it will allow you to better interface with the tool and to look at and manipulate your data. And so now that we have our GitHub account set up, we're going to install Anaconda. And so here, I'm just going to go and click on this link, and it's going to open in our browser. And so here, again, free download. So you can download it directly to your computer. And this works with Macs as well as PCs, depending on which operating system you're using. And so we're going to go ahead and click the download button. Perfect. And then you're going to see that this little file here has opened in the bottom, and you can see that it's loading. So I'm just going to click on that. Then once it has, you should see this setup screen pop up. And great. So now our Anaconda program has installed. So we see installation complete. And so we're going to hit the next button. And we'll hit next again, and then we will finish our installation. Great. So now, once your Anaconda operation program is installed, it will open up in a new window on your laptop or your desktop. And within this, you'll notice there are a list of different programs, which is great. So you have compatibilities to use a lot of different programs once you install Anaconda. But the one that we're going to be using with the open access tool that is available through your GitHub account that we downloaded in the first step is this one here called Jupyter Notebook. So now that Anaconda is installed and we know that we can launch Jupyter Notebook, we can continue on to the next step. And so we've now completed step one and step two, and we're going to go back and follow up with step three. So we're going to go back to our GitHub account. So if you remember, that's what we set up in step one. And in our GitHub account, we are going to find the repository where this open access tool is hosted. And so I've put the link here, and we're going to go into our GitHub account and use this link to download that repository. So we're going to copy this link here. And we only need the end half of this once we're already on and logged into our account on GitHub. So we're just going to copy in this portion of the link. We're going to go back over to our GitHub account. And now I already have this open from when we created our account. But if you don't have it open on your browser, you always can access it at github.com. It'll take you to a login window, and that's where you'll enter in the email address that you use to sign up and your password that you've used to create your account. Something that might be useful if you intend to use this really frequently is maybe just to save this as a favorite on your bookmark bar or in your browser, so that you can quickly access it when you need it. And so like I said, through our GitHub account, we are going to access this repository where this open tool is saved. So we're just going to copy and paste that link from before, and we're going to go search all of GitHub. And that's great. So we see one result has popped up, and this is exactly what we're looking for. So we're just going to click on this link. Perfect. So now we can see that the small water system tool, publicly hosted, is available here and ready to download. And so you'll notice that there are 3 files listed here. So there's a README file, and that's displayed down here. It just gives you a short description of what this tool does. And then we have this file here. So this is actually what we're going to launch through Anaconda and using Jupyter Notebooks. And then we also see that there's an Excel spreadsheet with some demo data in it. And so that's for you to be able to use and test with the tool with formatted data and to help you format your own data when you need it. So like I said, what we're first needing to do is to download this repository so that we can use it on our own computers. And so you're going to go up here to this green code button. What we're going to do is we're going to download this zip file. And so we can see now this zip file is downloaded, and we're going to open this, and we're going to extract it into the location that we want to work with it. So these 3 files are now in our folder that we downloaded them into, which is great. And so again, just a reminder, the way that we did that is we hit this green code button, and we went down to this download zip file, and then we downloaded that file like you would any other file and extracted it to the location that we wanted on our C drive. So now that we've cloned the repository, what we want to do is we want to go back to our Anaconda program operator and open Jupyter Notebooks for the first time. And then we're going to launch our Jupyter Notebook. And when we click launch, this should open up into a new browser window, either in Chrome if you're using Chrome, or in Internet Explorer or Firefox, whatever it may be that you use for your browser. And so we'll see here that Jupyter Notebooks is opening. It might take a second the first time you do it, so just be patient. And then now we'll see this list of files. So you'll notice that this list of files looks the same as what's here in our C drive. So if I go back up a level, this list here looks the same as what's displayed here. And that's perfect because now we can see this small water systems tool folder. So we'll click on that. And now you'll notice that there is this little notebook icon here. So this is what Jupyter Notebooks, so this is an interface with Python, which is just a type of coding language. So you don't really need to worry about that, but this is basically just a user interface for you to open up the tool and then work with that tool with your data. So we're going to click on this, and this will open a new window for you. Let's take a second to load. And now this is the tool. So the tool itself is designed to work with an Excel file of all of your data. And then, as I mentioned in the workshop through the Small Water Systems Community Network, you can take this tool and you can use it with your own data and get an output that is useful to you. So right now, if you were to run this tool just the way it is with the data that you've now cloned from the Git repository, what it would do is it would use the demo Excel file that's in there. So if we click through and we just want to start at the top here and click run, we're going to click run all the way through these boxes here. And what it'll do is it'll just execute the code that's in here, and it'll show you how it's interfacing with that raw data, that demo file. And so once you do that, you'll have a chance to play around with that data, feel a little bit more comfortable, and then transition into adding your own data into the file. So this first bit of code here, and you can see that there are headers in here to help you understand what everything is doing. So this first bit of code is just importing all of the packages that you would need to analyze your data. So this you should never have to change. The second bit of code is for file management. So here, all it's doing is it's naming our data file. And so if we just go back over to our file explorer and take a look at the data file that we have, this is our Excel file here, our raw data demo. So it's just calling that file in, and it's reading it into our code environment here. And so that ran. And then this third bit of code, so this is just a check. So you just want to check to make sure that your data you're reading it actually makes sense. And so we run that and then run this here. What it shows is the first 5 rows of our data. And this looks correct. So we have our facilities and a number of columns with all of our different parameters of data that we're interested in. And so this is the spreadsheet. This is the data that we're going to work with to analyze. And so for you, if you were to upload in your own data, the only difference would be that you would have your own Excel file, you would have a different name, and you could change that here directly in the code and read that in. And then we're just going to do another data check here. And so this is just displaying all of the column information to check and see how many rows of data that we have and to see if there are any empty values. So again, this is just another check to make sure that you're taking the data that you have in an Excel spreadsheet and transferring it over into this environment, into this tool, and make sure that it all makes sense. So we see here we have a list of 36 different parameters that we're going to be looking at. And again, this might be different for your facilities depending on what your data looks like. But for this example, this is what we have. And then I won't go through all of this in the video, but essentially the next steps are to run a series of statistical tests. And it's all explained in the comments here. So the first check is to check if your data is normally distributed. And the reason for this is it will, depending on your data, it will then depend on which type of analysis is most suited to your data. So this checks if your data is normally distributed. And then it gives you an output to tell you if your data is indeed normally distributed. And so this little star here, when we click run, while that star is here, that just means that your data, your code is still running. And so until that star resolves itself, it just means that it's still working. And so here, now we see that the star is gone. And so that means this code has run. And we get an output here. So it says it skipped the test for our residential parameter. It skipped the test for the infrastructure age. And then it's saved results to normality test results. So if we go back to our folder, you'll see now that there are 2 different files that have shown up. We have our normality test results. So this is an Excel file. And then we have some histograms, which shows the distribution of our data. So this code automatically produces this based on our input data that we have. So if we just open up one of these, we see here we have a histogram of our boil water advisory periods. And we have histograms now for all of the parameters in this spreadsheet. So this is a quick way to produce really great figures and get a sense for how your data is distributed. And so we continue along and we run some more analysis on our data, just looking at Spearman rank correlation, all just different statistical analyses for interpreting how these parameters impact our small water system. And then we can create some plots with this data And again, just running this code. And it will take a second here. So we've done some correlation, and so what this code has done here is it's output some correlation figures, some scatter plots into a different file folder. And then we have here just a logistic regression. So all this is doing here is just calculating and predicting the probability of being on a drinking water advisory for the data that we're giving it. And so basically it's creating a model to be able to predict based on the different parameters you have in your data set, whether a boil water advisory would occur or not. And what that does here is it gives you this really great spreadsheet. So we just open our Google Drive. And again, you could open this directly with Excel if you have it on your laptop. And I'm just going to copy this over here so that we're able to open it and just take a look at what these coefficients look like. And here we go. So here we see a listing of all of our predictors. So in the case of the data set that we were working with here, we have all of our predictors. So boil water advisory in terms of days and how many periods. There were different parameters, such as if the facilities had certified operators or not, whether the systems had repairs, what type of treatment the systems had, if E. coli testing was done, how many connections the systems had. So all of these different parameters that you may be interested in, which may be affecting how your system performs. And then this coefficient here, this is basically a measure of how strongly that particular variable, so these variables on the left, how strongly that is likely to influence whether your system will be on a boil water advisory or not. And so how this particular tool has calculated this is based on the data that we've fed it. And so depending on the data that you have and depending on the variables that you're interested in, you can do the exact same thing and you can see, okay, of all of these parameters, which one has the highest impact on my system likely being on a boil water advisory? And then you can figure that out. And where this is useful then is that you're able to then allocate your resources and your time more appropriately to issues in your system that you may not have known about before. And so that's essentially just a very quick overview of how this tool works and how you can download it and interface with it on your own. So if you have any questions, my contact information is in the Word document. And you can reach out to me for any questions you have with downloading the tool, using the tool, or adapting it to your data. So I hope this was useful for you, and feel free to rewatch portions of it, as it may take a little bit of trial and error to get it working on your particular system. And thank you for your time today.